Good evening, and thanks for joining tonight's TI Technology webinar hosted by Texas Instruments, where tonight we're going to combine some football and some math. My name is Mike Houston, and I'm the moderator for this event. I teach algebra and calculus near Pittsburgh, where I use TI Technology to make tough-to-teach, tough-to-learn concepts for all my students. Tonight we're really excited to introduce our panelist, Brad Poznansky. Brad's in his 23rd year of teaching at Komsomog High School. He's been using TI technology in his classroom ever since he's student taught. He's a firm believer that you never stop learning, and that's evident in his pursuit of new and innovative challenges made possible through TI technology. Brad has presented at local, state, and national and international conferences. Brad coaches 3 varsity sports and loves to sail in the Caribbean. Brad, thanks for joining us tonight.
Thanks for having me, Michael.
We're expecting a large crowd, so your audio is muted. Feel free at any time to send questions to Brad using the Q&A window on the right side of your screen. We'll also be using the chat window to send general messages. As a reminder, this session is being recorded, and we'll provide a link to the event certificate of attendance at the conclusion of the webinar. We hope you don't have any audio issues, but in the event that you do, try selecting Communicate from the very top of the WebEx menu and choose Audio Broadcast. At this point, Brad is going to discuss our agenda.
First, we did our introductions. We're going to be finding data on professional football players and teams from a website that has a nice sized database for that. And taking that data from that website, properly formatting it in order for us to easily upload it to one of your handhelds, whether it's TI-84 or the TI-Nspire. Now, once we've successfully collected the data, we're going to view the data on those handhelds and make some conjectures based upon the results.
Thanks so much, Brad. And tonight we really hope that you walk away being able to put data into lists, and in doing so, that will help you make visual representations of that data, including histograms and box plots. And also, it's a really great way to discuss measures of central tendency and measures of spread, and how you can use those to analyze the data. And lastly, we hope that you're able to explore outliers and how they might affect the data set. All right, Brad, you should have control. Feel free to share your screen.
All right, here it is. All right, so one of the motivations behind this was to find real sets of data that the students could use, so that way they can make some comparisons. It gives them a little bit more meaning when it's the data that they've chosen, and also to motivate them to come up with different types of questions that they might have once they see and manipulate the data. Part of this was, if you follow sports, there's an ever-evolving analytics aspect of sports where companies and teams are trying to make decisions about their players and their staffs based upon a lot of statistical data that is available to them. So this was one thing that I thought of as far as introducing it to certain kids, as far as maybe the future of sports, and using some math to help them with that. And then just some possible questions that you could broach with the students, as far as, are there any physical traits that all pro players possess that would allow for a more focused player search? With hundreds and hundreds of college football players, what certain traits are the all pros have that the others do not have? You can compare positions. You could compare teams, drafted and undrafted. So there's lots of different fields that you can look at. And at the bottom here, I wrote something about discuss the BMI for data of players. Okay, that's the body mass index. They did have that data in here as well, and it's interesting to see and talk about how does that compare to normal non-athletic individuals. So one of the things we want to do is to get the students to think about the data that they themselves are going to collect, right? Give them some ideas, give them some the ability to go freely without it, and also so that way they're not just putting in data that's on some worksheet. So it gives them a little bit more meaning. Early in the school year, this is a good activity. First week of way of getting them to introduce them to the calculator, get them involved, get them seeing some of the stuff that they can do with the calculator. Measurements that they can make about themselves, right? So they can actually do some measurements on themselves and maybe compare it to some of these football players and see what their data looks like compared to them, right? Is their spread and their interquartile ranges similar in a sense? And you can take that data to class. And then having them input and really think about what they're seeing. So some of the things that you could do with your students just to start it off before you get into this football data is some measurements that they can themselves make in class. One of the comparisons is if you take the distance from your elbow to your wrist or wrist to your elbow, and you also take your foot size, so it's supposed to be the same size, that measurement. So you could do a scatter plot with this. Now, having taught ninth grade algebra, a lot of my boys would have really large feet and their rest of their body hasn't yet grown into themselves. So it's not necessarily a true one-to-one with that, but the girls usually have a better data set with this. But this is something that they can measure themselves. Also, it starts having them ask some interesting questions like, well, how do you measure your foot? Is it from your big toe to your heel? What part of it is the size of your foot? You know, are we measuring diagonally if we trace our foot on a piece of paper? So some of those things were brought up by the students as well. A couple other interesting just measurements that they can do is if they take their middle finger and their thumb and you wrap it around your wrist, they should touch the tips of those fingers. And if you take twice that measurement, which would be if you took your thumbs and your middle fingers and created a circle, that should be equal to their wrist or their neck size. So it's just another interesting type of thing that they can explore and they can measure and see how close they're related. Two others are the arm span from fingertip to fingertip should equal their height. So we could compare those two things. We could measure our students' heights. How many students would be kind of trying to be taller? Would they try to be sneaking up on their tippy toes to see if they're going to be taller than their friends? And then one other interesting one is if you take the circumference of your head, and the way you measure it is across your eyebrows, on the top of your ears, and around the back of your head. It's a measurement that's approximately 1/3 of their height. So again, getting them to see these things, and maybe like once they discuss them, you could see what their excitement is. So I'd like to. We're going to start out with doing some of this data gathering. I want to show everybody how easy it can be to get a large amount of data into your TI-84 or into your Nspire. The resource that I found was this Pro Football Reference. There'll be a link in the documents that accompany this webinar, and it allows you to explore all sorts of different statistics. I'm going to take you through a few of these slides just to talk about them, and then I will demonstrate what it takes to get them into your calculator. So a couple things is you could have students come up with their own search terms. All right, they could compare teams. They could all kind of drive that whole discussion. And we could have the students input this all by hand, and that would be perfectly fine. But that would also lead to a discussion of are there any errors in the data? And if you're looking to get a whole bunch of data from a particular team or a particular position, you're going to really wind up having too much to put by hand. All right, so they can look through different parameters. So on the site here, there's a couple ways of getting to the search field. So if you reference this website and the player index, and you choose a season, it'll take you to a page that looks like this. This is the search page, and you can search from 1920 all the way up to 2018. It updates it through the current game that was just played. So we're just shy of the Super Bowl, so it has all those statistics in there as well. You can choose positions, drafted, undrafted, what leagues they're in, what team they're playing for. And on the side, you have additional criteria that you could search through. So it's a very advanced search engine for all this data. You could probably go pretty, in depth on this. So, and they also do have the combine results, right, which are the physical testing of the players, where they time them in a 40-yard dash. They see what their vertical leap is. They bench press a certain amount of weight for a certain amount of reps. So all that data is in there, and that's from, I think, 2000 until 2018. So with this, I figured the students could compare. Maybe they go out as a class and in phys ed run a 40-yard dash, and they could take their times and see how their data looks compared to some of the professional football players' data. So in this search that I put in here, there's searches for offensive linemen and for the year 1970. And in the lower right-hand side, you could sort by height, you could sort by weight, you could sort by various fields. When that comes up on your screen, you'll see something that looks like this. All right, you'll get every single player, and they're listed by their height in this order. There's a Share and More tab, and in that Share and More tab, you can get this as a CSV file for Excel. So if I take you guys to this, right, here's your search field. All right, and we'll do a simple search of, if we find just, let's say, a running back, and we'll just use the year 2018. All right, we'll sort by height, and we'll go to Get Results. All right, so you'll get a list of, usually takes you to about the top 100 results. When you roll over the Share and More, that's when you get down to this Get Table as a CSV for Excel. All right, this is how we're going to import the data rather quickly. So we click on that. You'll get the data without the table. And what you'll do is you'll highlight it, and you'll copy the entire set. Copy it. And then if you open up an Excel file, choose the first cell, and you'll just paste it in there. And what you'll notice is everything gets pasted all in at once. There's no columns, just like a typical Excel file would have. So there is a Data tab at the top. From the Data tab, there is a command that says Text to Columns. Right? So this is what's involved in getting this all into your file. So click on that. You're going to want to choose Delimited. We'll go to Next, and then Next one more time. Now, you'll get all these columns in your Excel file. Right? Now, if you don't want any of them, what you could do is if you hold down Shift and click on the columns, you can say Do Not Import them. Right? One thing I do have to stress is their heights. They're listed as 6'3", 6'3", and so on, right? But this doesn't translate into 6'3". It'll just say 6-3. So on top of that column, you're going to want to choose text. All right, and I'll show you how you can convert this to inches very nice and easily. And then if we just get rid of these columns here, right, and hit Finish, now we have a nice 2 columns of heights and weights. Right. The one thing that you're not going to do is title the columns here with a height or a weight, because when you import it, it's not going to understand what that is. So there's a quick way of getting that information into your file. Now, one thing I do have to point out is you would keep collecting on the next page because there's more than 100 players. All right. And so with that in mind, all right, the first time I did this, I made a statistical error. I only collected the first 100, and I said, wow, the shortest person, it was a line that I was comparing, was only 6'5". So I made this conjecture that you have to be 6'5" to be in the NFL, as far as a lineman's concerned. So again, you learn as you go. All right. So once we're done collecting that, there's another piece of getting this into your TI-84. All right. And that piece is when we save it, we have to save it as a certain type of file. All right. And the file that we're saving it as is, I have a Mac here, so it's a .csv file. Right. So that .csv file is going to be a comma separated value file. This will allow you to import it into your TI-84. Right. One word of caution is if you have multiple tabs with different data in it, right, and you hit save, it's only going to save that particular workbook page. All right. One other thing before we get into importing it is we can change all these heights to inches, and you would do that by choosing Edit, Find, and then Replace. And so you can go through your entire workbook and change anything that was 6'3", and we can make that 75 inches, and you would replace all of them. All right. And you would go through and do that with all your various data. All right, so I do have a file that we can use with that. All right, so do we have any questions just yet? I just want to make sure. I know that was just a little bit of...
Not so far, Brad. I did want to let everyone know that I did post a link in the chat window.
Okay.
But it might still be best, even though I posted that everyone kind of follows along with Brad right now. But as a reminder, you are going to get a recording of this. So that way, with the recording, you can kind of go along your own pace as Brad's going through this. If you happen to miss one small piece, the recording is really the best way to get that. So I just want to jump in.
Okay. And before we start putting this into the 84 or the Nspire, I think it's important for the students to come up with their own ideas, right? You'll have, 7th, 8th, 9th grade boys or girls. They might want to look at their favorite teams, all right? So it gives them a lot of leeway in what they can collect, all right? You might want to steer them in certain ways. That way they can compare some things that might be a little bit easier to compare, like heights and weights. But there's all sorts of different pieces that they can compare within this. So the next thing, once you have that data all saved, you're going to need to open up TI Connect. Right, so this is a little bit of a step that involves using TI Connect. You'll connect your 84 via USB port, and you're going to open up the Calculator Explorer. All right. Why is it not connecting? Hang on. Technical difficulty. There we go. All right. And so what you'll do is you'll have a CSV file on your desktop. And if you take it and drag it into TI Connect, it'll ask you how many lists do you want to import. So I had, what I did is I had a bunch of 40-yard dash times. So I have 3 columns that I want to import. I'll hit continue. And it'll give me this screen to say you're going to send it to your calculator. You hit send. Something's already there. We'll replace those. Even if nothing's in your list, it still thinks that there's something in list 1, list 2, and list 3. So that's a way of doing it. So now, if you have only your desktop computer in your classroom and you want to be able to distribute this to your students, you could have the students link up to each other's calculators and send. Once you show them that skill, they're pretty quick at sending each other data. Right? So that's the first part of getting this onto your 84. Right? The next thing is we're going to take those lists that we want, and we're going to have to send them to our computer. All right, and the reason why I'm doing this is because if you want to display these on your smart view, just in case you want to be able to do some demonstrating for the class, all right, this is a way of doing that as well. So right now, those lists are on your handheld, ready to go with all the students. But if you wanted to use your TI Smart View as far as demonstrating purposes, this is how you would do it. So you would send it to the computer. It's going to say hit open, and because I have already these on my desktop, I'm going to just replace them. Right. So now, if you open up Smart View and the same magnifying glass Calculator Explorer opens this up. And here in this first icon, add content from computer. So we're going to add some content from the computer. And here are my lists. And we're going to open them. And we're going to send them. And again, replacing lists that might be there. Place and replace. All right. So now, finally, we got that data into our calculators. All right. So now we're ready to go with doing some exploration and viewing of the data. All right. So, within this, I like to, think about, as far as with the webinar, giving teachers ideas of things that they can do with their students. All right. You guys are in charge. All right. And the experts in your classroom. So, whatever you want to do as far as displaying this. Right. So, if we turn one of our stat plots on, right, and we go to first stat plot, we've got to decide how we want to display this. All right, and if you've had discussions about, is the data normal? What does normal mean? What does normal look like? All right, so you might have already discussed that with the students. All right, and so if we go and let's just take a look at the histogram of this. And so we'll choose the histogram, and then we'll choose a window. So if we zoom stat number 9, here's our data. All right, this data happens to be the 40-yard dash time of running backs in 2018 at the combine. Right, so if we take a look at this, this definitely isn't what we would consider a normal distribution. All right, it does have a skew about it. All right, so you can ask the students, what do you notice about this? Well, it's higher on the left, it's lower on the right. You can have them talk about that. Would they consider it a normal distribution? Depending upon, if you've introduced what normal looks like, they could comment on that. Talk about, where the tail of the data is going. All right, is it skewed right, skewed left? We could also discuss, where they think the averages or the mean of this data is, right, and so on. Right. So those are a couple ideas that they can discuss, they can talk about just by looking at this data, right? And you might want to look at it a different way. So if we go back and decide to look at this as a box plot and check it out here. All right. So we can see how it has a nice longer tail on this side. Here's our median. All right. And maybe we start discussing with the students, if there's a longer tail on the right, where's the mean going to be? Is it going to be the same as the median? Will it be to the right of the median, to the left of the median? All right, so you could discuss this with, I think I saw a question come up, which age? All right, you could do this in 9th grade algebra, depending upon maybe if you have an 8th grade statistics. Depending upon what level you're at, I think you could decide, where you're going to introduce some of these things. You might just want to have them looking at the data and just some simple mean, median, mode type questions. So in this data, here's what we have for our running backs. All right, and then we have some outliers over here. All right, and then we could get into the discussion of what is an outlier and how they determine an outlier. So the outliers are, if we take the interquartile range, if we trace this, if we could take a look. All right, so here, the first quartile is 4.62. All right, the third quartile is 4.7. So we could all take a look at, well, how much of a spread is that? From 4.62 to 4.7, it's 0.08. All right, so we have a tight group of data here where 50% of it is within 0.08. All right, as far as speed's concerned, I'm a track coach. That's real close. That would be a real close race between all those running backs. All right, we can take a look at the median. All right. So if we take that interquartile range, right, and we multiply it by 1.5, right, if we are 1.5 times that larger than this third quartile, that gives us these outliers. All right, that was something I just learned. There was a mathematician by the name of John Tukey who came up with this calculation of the outliers. And he worked a lot with data sets and statistics. And the story goes that when someone asked him why did he determine it at 1.5, he said 1 seemed like it was too few and 2 seemed like it was too many. So I'm sure there's a little bit more statistical research done with that besides just kind of a random 1.5. So now the other 2 pieces of data that I did collect here were other positions. So these were running backs, right? So you might spark a discussion with the student saying, well, what other position would you like to collect data for, right? And they might collect it, compare it to some other position. Look at this other one. All right. The next position that I collected it on was their wide receivers, right? And you might want to say, hey, where do you think this plot will be, right? If we take a look, go back to what we had, where do you think it would wind up? Is it going to be faster? Is it going to be slower? What about the spread? Will it be similar spread? Will it be tighter? Will it be wider? Will you have more outliers? Give them questions like that where they can, make predictions. Have them thinking before they just all of a sudden put it on their graph. So if we did take a look at those, we turn that on, right? And we go and got this histogram on, and we take a look. And here, right, we got to determine, is this faster or is this slower? Right? Well, we got to take a look at those particular times. And if we do trace it, we could see that, yeah, some of these times got a little bit faster, right? But is the spread, all right, the same? So if we went from 4.6 to 4.675, it's almost the 0.08 of the running backs up here, right? So it's a very similar type of spread. They're just a little bit faster overall as far as the runners and their times. And then one other that we put in there was the third plot, which was cornerbacks. The guys who have to cover those wide receivers, they have to be pretty fast as well. Now, do you think they're faster or slower? All right, so if we did turn this one on, it's not on yet. There it goes. And we see that they're even faster, right? Because they got to cover those wide receivers. And we go from 4.56 to 4.63. All right, so it's about 0.7. So it was a little bit faster, a little bit tighter spread than we did have with our running backs and our wide receivers. Right. So one other thing we might want to look at, I'll turn some of these off and turn this one off. Right, so we still have that first plot on, right, in a box plot. And when we looked at it with the histogram, we were wondering if it was a normal distribution, and we saw that it didn't look too normal. Now, one other feature we have here, or an additional feature, is this last one here, right? And this one deals with the normal distribution, or normal plot of the data. Right? If we take a look at it, if this data is normally distributed, it should almost form a straight line. All right, we should understand and get our students to understand that if we're dealing with real data, nothing's perfect. All right, so if we take a look here, and this is the data plotted, all right, and it should form a straight line if it's normally distributed. All right, and in the slides that I prepared, and I'll show you at the end, there's a formula or an equation for the normal line to be plotted to this. And oops, let's get to it here. If we turn this on, it's the x minus the mean divided by the standard deviation. If we take a look here, not even close. All right, it's got a little bit of curve down here, a little curve up here. So within these, there are going to be, some errors. Right? We already saw from the histogram that they're not normally distributed. All right, so these are just a couple ways of looking at our data, all right, and taking some analysis of them. All right. So I'm going to pause right there and see if we have any questions about what we've been doing so far.
Brad, I don't see any so far, but
Okay.
I'll let you know if some come in.
All right. All right, so that's with the 84. I also want to show some data with the Nspire, and as far as importing into the Nspire as well. I like to play with both these. All right, so with the Inspire, all right, so I just already took a lot of this data and imported it. So if you opened up a listen spreadsheet, you could take that data that you have from, I'll just take all this weight here, and you copy it, come to that first cell here, and you can just paste it right in. So it becomes a little bit more seamless than the 84 as far as importing it. If you have a navigator system, you can send this out to all your students right there and then. If not, you can get this onto you with your teacher software onto your Inspires, and then you can have the students linked together as well. Now, one thing you would always have to do is title this weight and whatever particular year it might be, so that it would label it. Now, what I've noticed is with the Mac version of this software, it winds up skipping every other. All right, so it wasn't it's not such a bad thing. It doesn't make a real difference when you're starting to view the data. But when I was importing it at work with my PC, it didn't have these skips. So there's a way of in the notes of sorting them and getting them all tight that way. So one thing I did is I took every single every single player in the NFL. All right, there's over 2,000 players in 2018, and I put them into this table here. All right, so they're all in there, and then I made a box plot of all the players in the NFL, and I was thinking to myself, oh, this looks kind of normal, all right, but I don't know if we could determine super normal from a box plot, all right, and got me to thinking because I started talking with the students. What's the average weight? All right, well, right here it says, well, the median player is 235 pounds, right? And if some of the students are astute enough to know about professional linemen, they were all pretty big guys, right? So I was curious to see this as a dot plot. So if I went to menu and plot type, and I went to number 1, dot plot, and this is what the data wound up looking like, right? So you had a whole group here, and then you almost had like a secondary group over here, right? And if we viewed that, we could view it as well as a histogram, right? Almost like seems like we have two groupings, all right? Now this grouping here probably is your lineman, all right? Your offensive lineman are a little bit bigger, and here you have more of your rest of your field of athletes. So if we took a look at each one of those individually, all right, so if I add a data and statistics page, and I'm going to add the offensive linemen, here they are, and then we could take a look and say, hey, listen, is this a normal looking plot with a histogram? Maybe. All right. And then the other thing that we could do with this, all right, is that normal probability plot that I discussed a little bit on the 84. All right, so if we plot this with the normal probability plot, and this is a nice feature where you can just toggle between these on the Inspire, is right in here you can see you have fairly normal, then obviously you have a little bit of a differential at the ends and the extremes. All right, so if we put this into box plot, there it is. All right. Now, in 2018, all right, we could take a look. Our spread is from 305 to 320, a 15-pound spread. Right? Then you have a lot of these outliers, right? And with students entering data, they might get outliers because they transpose the numbers wrong, right? And they might inputted it into the calculator wrong. But here, since we imported it from a table that was, from a web page, is less likely of a chance of having error involved in this. So if we take a look down here, this guy's only 260 pounds, right? So you might want to say, oh, where's this guy? Is he really strong? Is he really powerful? What's going on? Then you got somebody over here who's 380 pounds. So you have some extremes with these, all right? I wanted to look at these guys compared to the rest of maybe another group of players here where there might not be as many. all right, or I'm sorry, not as many, but as heavy as we saw, right? So we can actually look at that on the same field here. We add an X value. And if we took, let's say, the cornerbacks, we take a look at these guys, right? So also another little tight distribution. These guys went from 189 pounds to 200 pounds, right? So 5-pound spread, really tight little distribution. You still have some outliers within them. And here's your extremes, right? You had that upper and you had that middle or lower piece, all right? So that was an idea that we had. And if you follow football a little bit, all right, we took the weights and heights of our offensive linemen from 1970 all the way to 2018. And so this is a good place to have students, even if they have this data, make some conjectures, make some ideas about what would it look like, all right? You know, they know maybe most recently, but what do they think that linemen are going to look like in 1970? Are they going to be the same as current day, right? And if we go to start plotting them, all right, so this is kind of like how we just reveal it. We're going to start with 1970. So offensive line to 1970. And then if we put it into a box plot, here they are, all right? Now, here's where you could have your students make predictions, right? What is an offensive lineman going to look like in 1980, all right? And for some of you students, this is going to be kind of far out topic because I don't think many students know what 1970 or 1980 is, all right? Many of you guys might not either. I'm old enough to be, able to, think about those decades, but, most of our students might not, not have been born until 2000 nowadays, at least. So, we could, again, discuss the spread. You're going from 246 to 260. You have about a 14-pound spread. Is that typical? And if we added another one on the same graph, so let's take the offensive lineman from 1980. All right. So we're definitely seeing a shift. All right. They're shifting from a median of 251 to a median of 260. So we're seeing a trend that they're getting a little bit heavier. Also, we could discuss the outliers. Right? You only had a couple outliers here. Now we have a lot more. Right? What's happening to the players? You could even get into discussions as far as their training, their eating, their nutrition. Right? What happened over those years? Are people, and you may be able to compare this to regular society. Are people getting bigger? Are people getting stronger? Are people just becoming bigger and heavier? Types of things. So, and then I would do probably one more with the students where we would add one more variable to it, and we would collect maybe 1990. Right? And here you definitely see a big shift, two ways. Right? They could see that have the heavier, right, moved up in weight, and also the spread of the lineman. Here we go from 277 all the way up to 298. So it's about 20 pounds, where here it was it's about 10 pounds, 11 pounds. All right, so you can see that. I do see it, Mike. I saw a question coming in as far as is there a way of getting something, I think?
Yeah, Tara asked, is there a way to access these types of graphics or plots using the 83 plus? She said that she's kind of new to this, but the calculators, that's the calculators they have access to.
Okay, I think from what we did with the 84, that yes, you'll be able to get all the plots that you'll be able to get on the 84 will be the ones that we had. Oh, I got to change that. Hang on a second, I'll switch that up. You would be able to plot 3 of them on the 84 like this. So if you were using the 80, or I'm sorry, even the 83, you would definitely be able to get 3 box plots on that screen and be able to kind of do some tracing and looking at the data that way. So I hope that answers the question, that you would definitely be able to do it on the 83.
And if I could just add something, and that is that even if your students are, say, using the 83 plus, if you're using the SmartView software like Brad is, then you have all the access to the color and all the other possible updates that might be coming that way of the TI-84.
And even in Tower, even within that, we could go paper and pencil. We could, get a piece of graph paper and have them, once they've done these calculations and maybe not even have to do the plots, compare them, right, and say, where's it going to be? Making some guesstimates where they're putting their pencil and paper on paper, and seeing what happens, right, before they even see it. I think that's a valuable thing for making predictions, making students, empowering them to make mistakes or even just make predictions, right, and seeing if they're correct or incorrect with these. One thing that I thought of as this was occurring and taking a look at this information was, now that we have these three, sets of data on the screen, what about predicting in 2000 or in 2018? Are they going to keep getting bigger and bigger? Is there a top end to this? All right, or is it going to eventually, reach a size or that the linemen are just going to reach? So you can maybe even, talk to the students if they've done some stuff with some scatter plots or predicting, all right, for a median from 251, 10 years later, 260, then all of a sudden you make this jump to 286. What's going to happen the next year, all right? So I'm a big proponent of letting students make some guesses, all right? See if their guesses hold up. Why did they guess that, right? Is it what they thought it was going to be? And because I just couldn't help myself, I said, well, let's see what happens, right? So I spent a lot of time taking this data, putting it in there, and I think we have offensive linemen 2000. Here they are. So they are getting bigger, all right? Now, one interesting thing was I looked at these guys. They're all these 300-pounders, right, or 298 to 320-pound men. And all of a sudden you have this person down here, this outlier is 213 pounds and 237 pounds, right? Might bring up a discussion. Who are they? All right. I don't think, if you have all these big guys hanging around the line, that you're going to have these two guys on the line with them. All right. I have a sneaky suspicion that these guys are the guys who snap the ball to the punter during special teams, right? Because I don't think they're playing every single down. But also, again, let's look at that median. You went from 286, now we're up to 306. It went up another 20 pounds. So, of course, let's just check out 2018 to round it all out. And offensive line, 2018. And probably wasn't what you expected, right? As far as, it didn't increase it that much, right? But, again, let's talk about what happened to the spread. All right, you're going from 305 to 320, right? A lot smaller spread, all right? So maybe now they're finally figuring out what might be ideal for offensive linemen, right? So those are just all different comparisons. One comparison that I did do was also the heights, and the heights didn't vary much, right? And you can talk about that. Now, if you think about height, is there much variability between 6'2" and 6'5" or 6'7"? Compared to weights, which could be a much bigger range, right? So those are some just ideas that are there within this discussion. Also, I do have to just mention one of the people that was very helpful in putting this webinar together as far as leading me to the data and easily accessing it is one of our national instructors, David Scott, who was instrumental in talking me through some of the data pieces of this. So I just wanted to give him a little bit of a shout out as far as somebody who was behind the scenes with helping me out with this. But those are some of the data that was collected. Obviously, we could plot this, see how it looks. Is it normal? Is it not normal? So we can all take a look at different pieces of those. So I'll pause for a little bit for if we have some questions that you want to ask about this, as far as running through collecting it or displaying it with various means.
Brad, we had a question from Matt. Is there any difference using, say, Google Sheets to upload data instead of Excel?
Thank you, Matt, for asking that. I did check that out, and there is no difference with those. It will be able to save it as a CSV file. You could put it right into there. And what I would probably recommend, if possible, because I know a lot of our students all have Chromebooks and they're using the Google Sheets, is if it's possible to, I think you could download it as an Excel file, which makes it a little bit. And the only reason I say that is for when you're doing one of those little drag and drops into, if you're doing that into the TI Connect. If you're doing the Inspire like this, you can just put it right into there, the Google Sheet, and you'll be able to put it right into the list like this right here. So that's another one.
Thanks.
Okay. So, but and this is nice time of year to be able to do this with your students. You could have them pick their favorite teams, all right, and compare some of their favorite teams, and compare it with other people in the class. And as I said earlier, they could do it with a hand chart, checking it out to see what's reasonable. If we take a look here at this data in 1990, all right, if I create one of those, we could see if that looks fairly like it would be a nice normal distribution. So if we go check 1990 out, right, and then we could check it out two different ways. If we want to take a look at the plot and we check it out as a histogram, right? This one might have been in the middle a little bit, all right. And then if we want to also use that normal probability plot, number 4, right? Here we get nice visualization that they're pretty darn close to that line, all right. And so this would look like it was a fairly normally distributed set of data from the lineman from 1990, right? And again, this little equation, this is the line that they have, and it's x minus just winds up being the mean divided by your standard deviation. And this on the Inspire gets plotted automatically. If you were trying to do that on the 84, you would have to input it by hand, and that's what I had done in my y equals list here. I had already just plotted that. That's how I already had it in there. So again, going back and forth between the two, if you want to do that. So Ernesto's commenting, Tara. Okay. So any other questions, thoughts? How about your thoughts, right? As far as, what do you think about the data collection? What do you think about the students putting some of that stuff in? Okay, so I saw Ernesto talking to Tara about, same steps as far as 83 to the 84. Excellent. All right, anything else you could think of, Michael, that we haven't touched upon?
No, I think it was good. I saw Mark said very relevant this week. I agree. It's definitely something that my students can work on these next couple of days, at least on our end, where it's going to be pretty cold out.
Yeah, when I think about some of the teams that made it to the playoffs, and do they have any characteristics? I'm sure there are some certain characteristics, but I'm sure you can't beat the toss of a coin, or some sort of pass interference can always help you make the big game sometimes.
No doubt.
And even like if you take, and then the one thing I would probably, I did a long time ago, and it was definitely a big mistake on my part, is I think you could compare students' heights. I would really shy away from students' weights, all right, especially with kids of all different sizes, because if you do show a box plot with it and you have an outlier, and it could be an outlier that's on the heavier end, I think you have to take that into consideration as far as being considerate of your students, and that's one thing that I would just say that you wouldn't want to compare that to professional football players. I mean, take a look at their heights, have them run a 40-yard dash, do that type of thing as far as their distributions. Right. One thing I also wanted to point out with this in the 84, when we had zoom 9 here, right. this didn't seem too normal, right? This wasn't too normal. Brooke, I'll get to your question in 1 second about the TI Connect. Is would your students have a more normal distribution? Would they be more normally distributed than these professionals, right, and type of thing? So it'd be kind of a neat thing to consider. I think Brooke, TI Connect. I think that Michael, correct me if I'm wrong. Is that just a free download from the education.ti site?
Yep, I'm actually grabbing the link right now, and I'll post it in the chat window.
Okay, yeah. So TI Connect is that'd be a free way. It's free, and you could Mike just posted the link. So, yep, that's how you get that software, and then that's a good way of just getting it onto your handheld.
And just to be clear, the TI Connect is different than what Brad is showing right now. That's TI Smart View, which is you can get a free trial version of the Smart View. But the Connect, it has different capabilities. Connect is really just mainly there to help you, for sure, connect your calculator and what's on your calculator as far as files and applications with your computer. Smart View does that, and then it also has all the other capabilities of your calculator itself. It's actually a full-blown emulator.
Oh, and full disclosure on the TI Connect, it worked for us in this webinar because I had my fingers crossed. If you have the latest update for the operating system for a Macintosh computer, which is 10.14, occasionally when you drag that Excel file into this window here, it has crashed it, but when you bring it back up, it runs fine. So it's not foolproof. But if you just relaunch it, it'll take it. The folks at the tech support for Texas Instruments are aware of that. Because I guess Mac just released that update, and I happen to just update my computer, so it does work. Just if it crashes at once, just get back and run it again, and it'll be fine. Oh, question. All right. Is there similar data for other pro leagues? Yes. So I guess this one was the pro football here. They have, if you look up here in this menu bar, hockey, soccer, basketball at college, baseball. So there are a ton of different sports, and they all work, I'm pretty sure they all work exactly the same way, where you can definitely get these downloaded into one of those files, right? So good question. Yep. Excellent. So we kept it to football this week, but I'm sure there's tons of other stuff that you can take a look at, and I'm always looking for data that might be relevant, that's not pre-canned, where they can take a look at stuff that they consider relevant or they're interested in, versus something that's on a worksheet. All right.
Hey, Brad, we just had a question from Jasmine in the chat window. I don't know if you if you saw that. Have you ever had students compare data from a previous season to the most recent season, and how often is the data updated?
Well, since I was working with this for several weeks, as far as just looking at different statistics. If you take a look right here, it says NFL scores with this little circle with a 4 in there. That's the 4 most recent, I guess, football games that they have updated in there. It doesn't look like they have the what was the most recent one? The championship games that they just played, right? But they do update quite regularly. So even within the season, I didn't explore like game-to-game data or updated, like, let's say, yardage or any of those types of statistics. I was just going with some simple heights and weights of players. So I would assume that if they're updating these particular statistics where you could see, they have passing yards and receiving yards for all these different players, that it updates fairly regularly throughout the season, or weekly if they can. When I did get in touch with this Pro Reference website, they were more than willing to allow me to use their website in this webinar, and they only asked that I give them proper credit. So if you are going to use that in anything that you might do, and even if you're doing a presentation somewhere or you're writing a blog, just give them some notice as far as credit for where you got your information from. But they were real helpful as far as this large amount of data in a easy gathering way. Cool.
All right, Brad, do you want to send things back to me?
Oh, yeah, sure. Okay, yeah, no problem. Hang on. All right. History view. Oh, wait. Why am I not? I'm trying Mike here. How do I do that?
Here, I got it.
You got it?
Sorry. Yep.
Okay. There it is. Okay.
Thanks.
No problem.
So as we begin to wrap things up tonight, if you do have any last-minute questions for Brad, try to get those asked. I know he'll do his best to try and get those questions answered. We are looking forward to the T-Cubed International Conference coming to Baltimore here in just a few weeks. I saw an email come out today that said there's another couple days left if you're interested in getting some early bird pricing. I believe that's ending soon. Please feel free to visit our website to learn more. But it really is a great conference. I met Brad there some years ago, and so it's just a nice place to be able to work with common-minded teachers that are excited about education and passionate about technology. And so please feel free to learn more and join us at the T-Cubed International Conference. When you leave the webinar tonight, a brief survey will automatically appear in your browser. Your feedback guides us as we plan future online events, and we really do listen to your feedback, and we hope you share your thoughts in the post-webinar survey. Feel free to stay connected tonight and continue the conversation on any of the major social media outlets. To receive a certificate of attendance, go ahead and click the link in the chat window. Also, this is a link for the documents that Brad used tonight. And if for some reason these links aren't working for you, just hang tight. You'll automatically get a follow-up email within a couple days. And in that follow-up email will be a link to the recording, a link to the certificate, and a link to the documents from tonight. And if you're watching this on demand, go ahead and copy that link into your favorite browser to receive your certificate. Lastly, if you're in need of any post-webinar follow-up, feel free to give us a call at 1-800-TI-CARES or drop us an email at ti-cares@ti.com. We'd love to hear from you. Thanks so much, Brad, for everything you shared tonight. Typically, we have two panelists that work with us each Tuesday, and Brad agreed to do this solo. So, Brad, thanks so much for working with us tonight. I appreciate it.
Thank you, Michael. It's a pleasure.
And thanks, everyone, for hopping on tonight, and we hope to see you back online real soon. Have a great night.
Good night.